This lesson is going to cover 11.7, and there is a YouTube video online already uploaded to Canvas, but now that I've kind of had a chance to review them, the chalkboard lessons tend to be a little bit, obviously they're a little bit narrow, and so I thought I'd just go over this one more time, just in case you needed it something a little bigger, brighter, things like that. So one more example of completing the square to find the vertex, and then we're going to go ahead and graph this. So I'm going to pull out this coefficient here, and I'm just going to pull it out from the first two terms. So I'm going to pull that 2 out. We're going to be left with x squared plus 8x. And then we'll leave that space right here. And then I'll add in that 23 in the back. And then we're going to leave a space right there. And we know we need to do opposites between these two numbers here. They will be opposites. Until we go through the problem, we won't really know in the back whether or not that'll be a positive or a negative, so I'll touch on that one more time. This is what we're going to take half of. So we're going to take that 8 and we're going to divide by 2, get 4, square it, and it becomes a 16. So I'm going to go ahead and plop a 16 right here. But if I imagine myself distributing right here, 2 times 16 is really a positive 32. So in order to balance, since my equal sign is right here, and in order to balance my equation in the back here, I'm going to put a negative 32. And then I'm going to simplify everything. So I'm going to have f of x equals that 2, parentheses. Now I'm going to factor inside that parentheses. It's always going to be this number, whether it's positive or negative. So since that is a positive 4, it's always going to factor to that. So if I didn't mention that in the previous video, there's a little hint for you. Squared, and then a positive 23 and a negative 32 make negative 9, I believe. All right. I'm double checking my math there. Okay, so that means my vertex is at, always goes opposite same, so negative 4 comma negative 9. I know it opens up, so I'm going to do a pretty rough sketch on this one because I feel like we've probably covered the how to graph part of this. All right, so negative 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So kind of rough there. So there's negative 4, negative 9. If I plug in any number here for x, let's see if I get too big of a number if I plug in 0. 16 times 2 is 32. Take away 9. I really don't want to go up 33 or 32 minus 9, 23 spaces. So let's pick maybe x equals, let's try negative 2, just to make that a little bit smaller. And so 2 times negative 2 plus 4 squared, take away 9. 2 squared, this would be a 2. So 2 squared is 4, times another 2 is 8. 8 take away 9 is negative 1. So there's my y value. So negative 2, negative 1 is right there. We know now I have all these fancy tools at my disposal with my new toy that I have here. So there's my axis of symmetry. And so you can see I'm 2 to the right, so I'm going to have another space here, and I'm going to go 2 to the left and down 1. And so my graph will roughly, let's see if drawing is not my strong suit with this pen. I kind of missed the mark there, but you get the idea. So when in doubt, just kind of go back and make my line a little thicker. There we go. So there's a rough draft of what that looks like. Okay. The next part that is in 11.7 has to do with x and y intercepts. If I imagine, I'm not graphing what you see, I'm just illustrating what x and y intercepts are. Here is your x-axis, here is your y-axis. Right there, that's the point where the parabola intersects the y-axis, so that's called your y-intercept. Here are the 2 points that the parabola intersects the x-axis, and so these are both known as the x-intercepts. We could have an example where we cross in 2 places. Again, I am not trying to graph the function that I have drawn. I could have a situation where it just touches once, goes up and down like that. Okay, or I could even have a parabola that doesn't intersect the x-axis at all. And so why this might continue on and eventually intersect that y, it's never going to intersect the x-axis. And I could have that equally drawn something like this. All right, where it would never, ever, ever cross the x-axis at all. So there's a lot of variety with the x-axis. So not every parabola will have an x-intercept, but every parabola will have a y-intercept. So here's what we do. For the x-intercepts, we're going to plug in y equals 0 and solve. For the y-intercept, we are going to plug in x equals 0 and solve. One direction is markedly easier than the other. The y-intercept always goes a little bit faster because we're just going to plug in x equals 0. So instead of the f of x, let's call it y. So I would have y equals 0 squared minus 2 times 0, take away 15. And so you can tell that those first 2 terms pretty much drop out. And so my point here would be 0, negative 15. Over here, if I plug in y equals 0, it is not quite as easy to solve. Now we are looking back on what we learned in lessons 11.1 and 11.2. The first thing I would obviously try is to factor before I jump into either complete the square or the square root method if it's already in vertex form, or quadratic formula. I would check factoring first. My first example does factor to x minus 5, x plus 3, which makes my 2x answers a positive 5 and a negative 3, which means that one point would be written as 5, 0, and the other point would be written as negative 3, 0. So they would both be the x-intercepts, and then 0, negative 15 would be your y-intercept. Notice this isn't the vertex. This is just the y-intercept. So if I wanted to find the vertex here, I would need to go through that process of completing the square. And so if you were asked to graph this and illustrate where the intercepts were on the graph, I would set it up to complete the square. And this is not what the problem asked us to do. I'm kind of just pulling it all together here. And so half of negative 2 is negative 1, squared is 1. If I write a positive 1 here, I would have to write a negative 1 here to balance that. So we would have x minus 1 squared, subtract 16, which means my vertex would be at positive 1, negative 16. And so if I really roughly sketch this and we imagine that this was at negative 16, we would go all the way, and this was at positive 1. We would go all the way down here. That next point there, negative 15, would be where this crosses. And negative 1, negative 2, negative 3 would be one of my x-intercepts. And 2, 3, 4, 5 would be the other one. So, oh, I'm missing it. I'm missing it. There we go. I'm not a great drawer with this pen. It doesn't draw very accurately. I can write okay, so that's really rough, but you get the idea of the x-intercept, the y-intercepts, and how it interconnects with that vertex. All right, let's do the x and y-intercepts a couple more times. So, once again, I just like to organize my work this way, just something I was taught back in the day. You can organize it however you'd like. So I just make two columns. So if I plug in for 0 for y, if I try to graph, or excuse me, if I try to factor this, it is not going to work. So I'm going to have to use quadratic formula, which is a little bit of a pain. You could do complete the square method if you like that better. Negative b plus or minus the square root of b squared minus 4ac, a nice little review from earlier in the chapter, all over 2a. So 6 plus or minus 4 times 3 is 12. 36 take away 12 is the square root of 24 over 2. Let's break that 24 down. We're going to have 2 and 12, which is 2 and 6, which is 2 and 3. So it looks like I have a pair of 2's. One guy cancels. So I have 6 plus or minus 2 radical. That 2 and that 3 do not have buddies, so we remultiply them. And then if you recall how we handle something where all three pieces have a common factor, I can factor that out front in the numerator. So 3 plus or minus the square root of 6 over 2. And now I can cancel these 2's. And so the way we would write my x-intercepts properly is 3 plus, we're going to split it, 3 plus radical 6 comma 0. And 3 minus radical 6 comma 0. Those are the x-intercepts. Exact answers. If you need a decimal approximation, you can just throw that in your calculator. For the y-intercepts, we're just going to plug in x equals 0, and you can tell pretty quickly that that's going to drop out. This one's going to drop out, and it's just going to be y equals 3. So this side always goes a little bit faster, and so my y-intercept is 0, 3. I've got a few more here. X and y-intercepts, let's set it up. I suppose I could have done this in advance. X-intercept y equals 0. Y-intercept x equals 0. So if I plug a 0 in here, I don't like that this starts at the negative because I did set this one up to factor, so I'm going to factor out that negative 1. I'm going to get x squared minus 4x plus 4. My negative 1 can just divide out to the other side. So I can factor this piece right here to x minus 2, x minus 2, or x minus 2 squared. But I wanted to show you that we get 2 twice. So since it repeats, it's known as a double root. And so therefore, we only have to write it once. There is the x-intercept there. And when I plug 0 in for x on the other side, negative 0 squared still isn't going to do anything. So I was kind of lazy on that negative there. And y equals negative 4. So the point would be 0, negative 4. One more. We've seen a couple different types so far, just going back and reviewing. One where it factored, one where we had to use quadratic formula, one where we ended up with a double root. So now I wanted to show you just one quick example of how you could end up with no x-intercepts at all. So let's set this up. So I do not believe this is going to factor. I just know that it doesn't work. Let's just check real quick, see if it factors. X squared minus 2x plus 3. Yeah, no, that's not going to factor because it's a positive 3, not a negative 3. So we are going to have to use quadratic formula on this. And so b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I get 4 plus or minus the square root. 16 minus 4 times 2 is 8. 8 times 6 is 48. 16 subtract 48. I would just stop right there. You know, because you're not asked to solve. You're not being asked the same thing as what you were in 11.1. You're asking to find the x and y intercepts. So real numbers are the only things that are going to work because imaginary numbers will not show up on the graph. And the fact that we get a negative underneath this radical just reiterates that we have an imaginary number here. And so therefore it will not show up on the graph. And so there are no x intercepts. You can just quit right there. It will not show up on your graph. And I can graph this one real quick and show you how that's going to look. All right, on this side, we have y equals 2 times 0 squared minus 4 times 0 plus 6. So everything drops out but the 6. So 0, 6 is our answer. We know this parabola opens up. We know that it's going to be a little bit more narrow. So y equals 2x squared minus 4x plus 6. Let's just calculate that vertex really quickly. And I'll just throw out the graph for you to see. So half of 2 is -1, squared is 1. This represents a positive 2 if I multiply it through, so I'm going to put a -2 right here to balance that. So I have y equals 2x minus 1 squared plus 4. So it looks like the graph, oh, that's still orange, so sorry, kind of ugly. All right, so I have +1, +4, 1, 2, 3, 4. There's the vertex there. I know my y-intercept is 0, 6, so I can just use that as my point of reflection. Here is my axis of symmetry there. That line x equals 1. Since there's a point 1 space to the left, there's going to be a matching point 1 space to the right. And it graphs like that. And you can see that it never, ever, ever crosses the x-axis. And so therefore that's it kind of pulls it all together of why I ended up with a negative underneath the radical, because it's not a real number, and therefore it will not show up on my real number coordinate graph. So those are all the types of variations for the x and y intercepts. So I hope that was super helpful. And you guys are almost done, 11.8, and that is it. So take care, everyone. Bye-bye.